Hey guys, this is Mr. Beckstrom, and today I want to go over a problem that was asked about in class. This is on Wednesday, November 25th, and it says use technology to find the p-value for the hypothesis test described below. The claim is that for smartphones carrier data speeds at airports, the mean is equal to 12.0 megabytes per second. The sample size is n equals 17, and the test statistic is t is equal to 1.014. So let me show you how to do this one. And it is using that tool under our calculator. It's under second distribution, and that's the number 6, the TCDF. And I got confused on one little part, but it's actually not too bad of a problem. So this is a two-tailed test. So our claim in symbolic form, they give it to us right here. It's the mu is equal to 12.00. So that means our null hypothesis, and this is just a little bit extra here I'm doing. You don't need to do all this, but this is just so we get used to doing this. So our null hypothesis is always set equal to our claimed value, and our alternative hypothesis for two-tailed tests, that's when our claim is set equal to our claimed value, is not equal to our claimed value. And what they want us to do is they want us to take the test statistic. Remember, that's the critical value for our t here, which they give it to us. We don't have to find it. We don't either have to use the formula or our calculators to find it. They just give it to us, and they want us to take this and find the p-value. So what does that mean? Well, let me get this right, 1014. So that basically means that we have this t distribution here. This is a two-tailed test, so we got two tails in it. And the t here, the critical value, is 1.014. So that means we have 1.014 here. Critical value there, and then we're also going to have a negative 1.014 here, 0.014 there, and we're trying to find the area in both of those tails. We're trying to find the area in both of these tails. That's what the p-value is. The p-value is the area in your tails. So what is this area here? Doesn't really matter what our significance level is. It's not asking us to come up with any kind of conclusions. It's just asking us for the area in those tails. So there's really one way we can do this, and that's that we are going to take our calculator, and we do have a function for this using the t distribution. So we can go to second vars, that's our distribution. We can go to TCDF. And what that does is it's going to give us an area, and all we need to do is, for the t distribution, is plug in two of those values, and it'll give us the area between any two values. So here I can either go from like negative infinity to negative 1.104, and then I can double that to get this one and this one. Or I could go from 1.014 to positive infinity. I could find that tail and double it. Or if I wanted to, I could find the area in this main body and then subtract it from 1. Any of those would be fine. So in this case, I'm going to go ahead and find the area in this main body. So I'm going to go from this point to this point, and then I'm just going to end up subtracting that from 1, and because the total area has to equal 1. So let's do it that way. So 3 valid ways to find this. So I'm going to go from, and remember, if I'm using negative infinity, I can just use negative 9999 because the area beyond that is just so incredibly small it's insignificant. And the same thing for positive infinity. Instead of using that, I can just use 9999. But here I'm going to go from negative, don't forget to use that negative key, not the minus key, negative 1.014, and my upper limit is going to be 1.1.014, My degrees of freedom is 1 less than my sample size. My sample size is 17. So my degrees of freedom is 16. So this is going to give me the area from here to here. So this is my main body. And that is this amount here. I'm going to say 1 because now I know that that's the amount of area here. So my area in my tails is going to be 1 minus that, right? So it's going to be 1 minus, and I'm going to do second answer. That'll give me that last answer here. And so my p-value is 0.326. So that is my p-value. So my p-value, that's a horrible p-value. P-value is equal to 0.326 approximately. Let's see if we would have gotten the same thing if we would have done it like here to here and then multiplied that by 2. So let's just see. So if I would have done this, and I would have gone here, and I said, well, instead of doing that, let's go from negative 9999, which is kind of the same thing as negative infinity for this particular use, all the way up to negative 1.014 with the same degrees of freedom because it's 1 less than the sample size. And I found that, and then I'm going to multiply that by 2 to find both tails. And notice, oh, did I put some? Oh, I put that in wrong. The second limit. Let me do that again. Second vars. Okay. Oh, see. Okay, negative 1.014. I must not hit that one key. Do that again. And multiply that by 2. And notice I get the 0.326 again. The same thing I got the first time. So lots of different ways to solve this problem, but in the end, this is your p-value. And if I was doing a one-tailed test, if this was a less than or a greater than, then I would just have one tail and I wouldn't have to multiply by 2 at the end. All right, if you have any questions, let me know, and I hope you have a great rest of your week and have a very nice holiday. Thanks. Bye-bye.